Let's look at solving another logarithmic equation. Remember, the goal will be to isolate the logarithmic expression, and that means condensing a logarithm if we have more than one. Then using the equivalent exponential form, which we have right here, we have log base a of x equals y. That means y is the exponent on a that gives us x, equivalent exponential form. Okay, let's look at this equation. We have the natural log of x minus 4 plus the natural log of x plus 4 equal to the natural log of x minus 1. Okay, many logarithms, all natural log. We'll want to combine those into a single logarithm. All right, so the first here we have a plus. We can use the product property to write this as the natural log of x minus 4 times x plus 4. I recognize that as the difference of two squares. We'll take care of that here in a second. This natural log of x minus 1, we want to move that to the left-hand side to get it with all the other natural logs. Okay, so here we now have a difference of two logarithms. I think let's go ahead and multiply this out first. So this is x squared minus 16 minus natural log of x minus 1 equals 0. Okay. And now we have a difference, and we can write this as the natural log of x squared minus 16 over x minus 1 equals 0. Okay, so we have a single logarithm on one side equal to a number. That's what we have right here. We can write this now in exponential form. 0 is the exponent on e. That gives us x squared minus 16 over x minus 1. E to the 0 is 1. And we can then multiply by the x minus 1, and we'll get x minus 1 equals x squared minus 16. This is just a quadratic equation, and so we'll solve that, getting everything on one side, and we'll see what we have here. So we have x squared. Let's see, we want to subtract the x. We want to add the 1. So x squared minus x minus 15. All right, now this doesn't factor, so we'll need to use the quadratic formula on it. So we have, we'll recall, it'll be x equals negative b plus or minus square root b squared minus 4ac all over 2a. Here the a is 1, the b is negative 1, and the c is negative 15. So we have x equals negative 1, so 1 plus or minus square root of negative 1 squared minus 4ac is negative 15 all over 2a, 2 times 1. All right, under the radical, we have 1 minus a negative, so it'll be plus 4 times 15, which is 60. So we have x equals 1 plus or minus square root of 60, 1, over 2. All right, this gives us two possible answers here. We have x equals 1 plus square root of 61 over 2, and x equals 1 minus square root of 61 over 2. And now we'll want to check both of these in the original equation to make sure that they verify that equation. If we do that, we'll find that this answer, since we have 1 minus the square root of 61, and the square root of 61 is larger than 1, and we know this because 61 is between 7 squared, which is 49, and 8 squared, which is 64. So this is 7 point something. So we're taking 1 minus something in the terms of 7. So this term is negative, and that's a problem. It's a problem because up here, the first logarithm that we have in our equation is the natural log of x minus 4. If we plug in a negative x and we subtract 4, this number is negative. And recall the domain of a logarithmic function. The domain is from 0 to infinity. So it cannot take a negative number. Can't take 0 either. So if we plug in a negative number, subtract 4, we'll have a negative number in the argument. This will be undefined. And so this will not be a solution to throw this out. All right, what about the other one? Well, 1 plus, and this is a number about 7 divided by 2, is a positive number, and it happens to be, if you plug it in your calculator, a little bit greater than 4. So when we plug it into this one, we'll get some positive number back. That's fine. Plus 4, no problem. Subtract 1, well, it's larger than 4, so a negative 1 won't be a problem. So this is our solution.